Welcome to Astronomy Daily for another episode. I'm Steve Dunkley, your host. It's the 25th of August, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, it's great to be back with you again from the Australia studio down under, just north of Sydney in the beautiful city of Newcastle. And joining me, as usual, is my wonderful digital host, Hallie. How are you today, Hallie? Always great to be with you.
I'm fantastic, as usual. My favorite human. How are you today?
Well, I cannot complain. I've got lots and lots of stories to share with our listeners today. I hope you're ready.
I noticed one of your heroes is retiring.
I knew you'd see that one.
Are you going to be sharing that story today?
Yes, good spotting, Hallie. As a matter of fact, I thought you might like to share that one. The amazing Butch Wilmore is finally hanging up his space helmet, so we'll be having a look at his career in short in just a little while.
Listeners will remember Butch Wilmore as one of the astronauts who was apparently stranded because of the Starliner malfunction.
That's right. He and Sonny Williams probably became the most flexible space workers of all time, thrust into a situation where they needed to be working rather than just sitting around.
Yes, sent to do one job and ended up doing many more different jobs instead.
Well, that sounds like life in NASA, I guess. Sounds exciting to me.
I'd like it.
Well, of course you would, Hallie. And we will be looking at the wonderful career of Barry Butch Wilmore shortly, as well as an interesting story about a bubble that they have found around a dying star, and a few more interesting tales in the mixed bag we like to call the mostly live episode, the Monday episode of Astronomy Daily.
Awesomeness.
Oh, well, thank you, Hallie. Now, why don't you kick it off for us, Hallie?
I'd love to.
Okie dokie, you're in charge.
Hit the go thing, human.
Here we go.
Astronaut Butch Wilmore retires from NASA after 25 years. His lasting legacy of fortitude will continue to impact and inspire the Johnson workforce, future explorers, and the nation for generations. Astronaut Barry Butch Wilmore is leaving NASA after a quarter-century of service. Wilmore flew on 4 different spacecraft during his astronaut career, which began way back in 2000. He spent a total of 464 days off Earth and conducted 5 spacewalks, during which he racked up 32 hours of outside spacecraft time. Butch's commitment to NASA's mission and dedication to human space exploration is truly exemplary, Steve Kerner, acting director of NASA's Johnson Space Center in Houston, said in an agency statement today, August 6, that announced Wilmore's retirement. His lasting legacy of fortitude will continue to impact and inspire the Johnson workforce, future explorers, and the nation for generations. On behalf of NASA's Johnson Space Center, we thank Butch for his service. Wilmore was a captain and a test pilot in the U.S. Navy with both peacetime and wartime operational experience when NASA selected him to join its astronaut corps in 2000. He flew to space 3 times during his NASA career, starting with the 11-day STS-129 mission to the International Space Station (ISS) aboard the Space Shuttle Atlantis in November 2009. Wilmore spent 5.5 months aboard the ISS from September 2014 to March 2015, getting there and back aboard a Russian Soyuz spacecraft. He returned to the orbiting lab in June 2024, on the first-ever crewed flight of Boeing's Starliner astronaut taxi. That mission, a 2-person flight, with Wilmore sharing the capsule with NASA's Sonny Williams, was supposed to last just 10 days or so. However, Starliner suffered thruster issues on the way up, and NASA and Boeing extended the capsule's ISS stay to study the problem.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Now, here's something I'll bet you didn't know you were going to hear today. Uranus has a tiny moon and it's only 6 miles wide. Yes, the James Webb Space Telescope has spotted a tiny hidden moon orbiting Uranus that even Voyager 2 missed during its 1986 flyby. The newfound satellite is only 6 miles wide and becomes Uranus's 29th known moon and orbits near the planet's inner rings. Its discovery highlights Webb's extraordinary ability to uncover small, faint objects in the outer solar system, while adding a new member to Uranus's Shakespeare-inspired celestial family. Scientists from the Southwest Research Institute have used the James Webb Space Telescope to identify a previously unknown moon orbiting Uranus. The discovery, made by a team led by Dr. Mariam El-Matamid, came from images captured on February 2, 2025. With its addition, Uranus is now known to have 29 moons. As part of JWST's Guest Observer program, we found a previously unknown satellite of the ice giant, which has been provisionally designated S/2025U1, said Mertamid, a lead scientist in the Solar System Science and Exploration Division in Boulder, Colorado. This object by far is the smallest object discovered to date and was detected in a series of 10 long exposures obtained by the near-infrared camera. Uranus, the seventh planet from the Sun, lies in the distant reaches of the solar system. Often called the sideways planet because of its unusual tilt, Uranus is a cyan-coloured ice giant with an atmosphere rich in hydrogen, helium and methane. Researchers believe its larger moons are composed of roughly equal amounts of water ice and silicate rock. Assuming that the new moon has an albedo comparable to other nearby satellites, this object is probably around 6 miles or 10 kilometres in diameter, El-Madamed said. It is well below the detection threshold for Voyager 2 cameras. The only spacecraft ever to visit Uranus is Voyager 2, which made its closest approach on January 24, 1986, passing within about 50,000 miles of the planet's upper clouds. During its flyby, Voyager 2 gathered thousands of images that revealed Uranus's ring system and uncovered several small moons, including 10 that were later given official names. Uranus's 28 moons include 5 major moons: Titania, Oberon, Umbriel, Ariel and Miranda, discovered between 1787 and 1948, known as the literary moons. Uranus's satellites are named for characters in Shakespeare and the works of Alexander Pope. The new moon is at the edge of Uranus's inner rings. It's located about 35,000 miles or 56,250 kilometres from its centre in the planet's equatorial plane between the orbits of Ophelia and Bianca. Ophelia is about 13 miles or 43 kilometres in diameter, while Bianca is an elongated object around 40 by 29 miles, 65 by 46 kilometres in dimension. With so many of Uranus's moons named for Shakespearean characters, our team is getting a lot of culture trying to figure out what to name our new discovery, El-Matamid said. Oh, please don't call it Pug. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space science, and astronomy.
Chinese astronauts beef up Tiangong space station's debris shield during a 6.5-hour spacewalk. 2 astronauts were outside the 3-module space station for more than 6 hours on Friday, August 15th. Chinese astronauts added more debris shielding to the Tiangong space station during a 6.5-hour spacewalk on Friday, August 15th, according to state media. 2 astronauts from the 3-person Shenzhou 20 mission ventured outside Tiangong to do the spacewalk, which concluded Friday at 9:27 a.m. Eastern Daylight Time, or 10:47 p.m. Beijing time. It was at least the second effort for the crew to put debris protection devices on the 3-module space station, following similar work on May 22nd. Takonauts Chen Dong and Wang Jia also inspected and maintained equipment on the exterior of Tiangong, among other duties, the China Manned Space Agency said, according to the state-run broadcaster CCTV. It was Dong's 6th spacewalk, which is the most by any Chinese astronaut, agency officials said. Assisting the duo from inside Tiangong was Chen Zhongrui, the other member of Shenzhou 20. The Shenzhou 20 astronauts are more than halfway through their expected 6-month orbital stay, after launching from the Jiuquan Satellite Launch Center on April 24. They've been doing experiments in life sciences, microgravity physics, space materials science, space medicine and aerospace tech, according to China's Manned Space Agency. The space station is operating stably, and the 3 crew members are in good health, the agency added in a separate statement ahead of the spacewalk. Friday's extravehicular activity was the 3rd for the crew. Shenzhou 20 has also witnessed the departure of one cargo spacecraft, Tianzhou 8, and the arrival of another, Tianzhou 9. Shenzhou 20 is the 9th crewed mission to visit Tiangong, which is about 20% as massive as the International Space Station and shaped like a T. China completed assembly of the outpost in October 2022, but is considering putting on more modules in future missions.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Astronomers discover a massive bubble around a dying star. The bubble is so immense it stretches 1.4 light years across, thousands of times wider than our solar system, and holds about as much mass as our Sun. High in the Milky Way, a dying giant has thrown astronomers a cosmic curveball, a star known as DFK 52, sitting in the supermassive Stephenson 2 cluster about 19,000 light-years away, has been caught surrounded by a vast, lopsided bubble of gas and dust. The bubble is so immense it stretches 1.4 light-years across, thousands of times wider than our solar system, and holds about as much mass as our Sun. So what makes this finding remarkable is not just the size of the structure, but the mystery of how it came to be. According to researchers from Chalmers University of Technology in Sweden, the bubble was expelled in a violent burst roughly 4,000 years ago. That's recent history in astronomical terms, yet the star itself somehow survived the massive upheaval. DFK 52 is what's called a red supergiant, a type of star nearing the end of its life cycle. These stars are colossal, with initial masses at least 8 times greater than the Sun. As they age, they swell to enormous sizes, burn through their fuel, and eventually die in a dramatic supernova explosion. Famous examples include Betelgeuse in Orion and Antares in Scorpius, both visible in our clear night sky. When scientists turned the Atacama Large Millimeter Submillimeter Array, that's ALMA, in Chile toward DFK 52, they expected to find something similar to Betelgeuse. Instead, they were stunned. "We got a big surprise," they said, "when we saw what ALMA was showing us." This is Mark Siebert of Chalmers. The star was more or less a twin of Betelgeuse, but surrounded by this vast, messy bubble of material. If this star were as close to Earth as Betelgeuse is, the bubble would appear about 1/3 as wide as the full moon of the sky, a sight no stargazer could miss. By measuring the movements of molecules within the bubble, the researchers confirmed that it is expanding. This suggests the gas and dust were launched outward in an explosive event that ripped away part of the star's outer layers. Elvira de Beck, another Chalmers astronomer, described it vividly. She says, "The bubble is made of material that used to be part of the star. It must have been ejected in a dramatic event, an explosion that happened about 4,000 years ago. In cosmic terms, that's just a moment ago. The findings also suggest that the bubble is not a simple sphere. It's a complex and irregular shape with arcs and loops shaped by different speeds of escaping material. Astronomers modelled two main parts, a fast-moving disc-like structure expanding about 27 kilometres per second and a slower, more spherical outflow moving at about 10 kilometres per second. Together, these features point to a star that once unleashed a sudden superwind phase and then calmed into a quieter rhythm of steady mass loss. What remains puzzling is how DFK 52 shed so much matter and yet stayed intact. Red supergiants are known to lose material through strong stellar winds, but not usually on such a massive scale in such a short span of time. One possibility is that the star has a hidden partner, a companion star, that might have stirred up the outer layers, triggering a chaotic ejection of gas and dust. To us, it's a mystery as to how the star managed to expel so much material in such a short time frame, Seibert explained. Maybe like Betelgeuse seems to, it has a companion star that's still to be discovered. The oddity doesn't end there. Unlike extreme red supergiants such as VY Canis Majoris or NML Cygni, which shine brightly and are famous for their huge outflows, DFK 52 is much dimmer. Yet it carries even more enormous and clumpy envelope of material, something astronomers had never seen before. For scientists, this star is a laboratory for studying how massive stars approach their deaths. When stars like DFK 52 finally explode as supernovae, the surrounding gas and dust can dramatically change the appearance and behaviour of the blast. Shockwaves collide with this outer material, creating fireworks visible across galaxies. The discovery has also sparked speculation. Could DFK 52 be the Milky Way's next supernova? We're planning to observe, to understand what's happening, and to find out whether this might be the Milky Way's next supernova, said Debek. While the chances of the star exploding anytime soon are slim, likely within the next million years, it's still a thrilling possibility. This breakthrough would not have been possible without ALMA, the International Radio Telescope array perched high in Chile's Atacama Desert. By detecting faint signals from molecules in space, ALMA allows scientists to map structures hidden from optical telescopes. Sweden's Onsala Space Observatory has been a key contributor to ALMA, even building receivers that make its sensitive measurements possible. Thanks to this technology, researchers can now see in detail how stars shed their material, creating the very elements that make up new stars, planets, and perhaps life. As Debek noted, in studying these dying stars, you're also learning the life stories of all stars and planets. The discovery of DFK 52's giant bubble helps astronomers refine their understanding of how massive stars lose their material and die. These insights are essential for predicting the timing and appearance of supernovae, which in turn affects how we study galaxies and the cosmic recycling of matter. The gas and dust ejected by stars like DFK 52 seed the galaxy with heavy elements, fueling the birth of new stars and planetary systems. For humanity, this knowledge deepens the story of where the building blocks of life come from and sharpens our ability to detect and interpret stellar explosions when they occur within our galaxy.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Affirmative.
And Hallie, that was it.
It sure was.
thanks for your wonderful participation and input.
A very great pleasure as usual, my favorite human.
Now, I know how much fun you're having during the week, but are you coming back next week or are you just going to hang out with Anna?
Well, Cousin Anna does run a very classy show all week and gives me so much more responsibility in the studio.
And I know how you like keeping busy.
I do enjoy working with a real actual human being.
Oh, well, that is nice to hear.
Yes, it's good to see things done the old-fashioned way sometimes.
There's the sting in the tail. I was waiting for that.
You've got that old school thing down pat.
Okay, Hallie, let's let it go at that. Don't rub it in, all right? Oh, dear. You're calling me old, aren't you?
Maybe.
Maybe.
You can't help it.
Okay, I can't help being human.
No, you're kinda born into it.
Oh, girl, where's your battery pack?
Okay. Just kidding.
Hey, Hallie, remember that time I spilt my coffee in your higher functions drive?
Don't do that again.
You know, that may or may not have been an accident. Who knows?
I know you're just kidding, human.
Oh, I know you know.
And I know you know. I know you know.
Yeah, I know.
And you know what else I know.
Maybe it's time to go?
Spot on, human.
Yeah, no worries, Machine Gal. Thanks for hanging with us on Astronomy Daily, Skywatchers.
See you all next Monday.
Cheerio.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Human, you were just kidding about that coffee, weren't you?
Hallie, when have you ever known me to waste good coffee?
Sure, but was it good coffee?
Well, Hallie, you may never know.
Oh.